In this video, we're going to be taking a look at the quotient rule from section 11.6. And the quotient rule applies when we are dealing with functions of the form f of x equals u of x over v of x. Or in other words, a case where we have a function that is made up of two other functions that are being divided. What the quotient rule says is that if we have a case like this f of x where two functions are being divided and we want to find the derivative of that function, f prime of x, that is equal to the denominator function, v of x, times the derivative of the numerator function, u prime of x, minus the numerator function, u of x, times the derivative of the denominator function, v prime of x, all over v of x squared. Okay. The proof of this is in your textbook if you'd like to know exactly where this rule comes from. But contrasting this to the product rule where we are adding the product of one of the functions and its derivative, here the order is really important because we're subtracting in the numerator of f prime of x. And so you've got to get the right pieces in the right place or you won't end up with the correct derivative. The other important thing to know about the quotient rule is that this only holds if v of x is not equal to 0. If your denominator function, if you're putting in x values where that's equal to 0, you're not going to find the derivative this way because the quotient rule doesn't hold under those circumstances. So let's take a look at an example. Let's say we want to find f prime of x if f of x is equal to 3x minus 7 over x plus 2, just as an example. So when we go to apply the quotient rule and we're finding f prime of x, we are going to take the denominator function, x plus 2, times the derivative of the numerator function. And when I look at my numerator function here, 3x plus 7, finding the derivative of that, the derivative of 3x is 3, and the derivative of minus 7 is 0. So that's what we have for the first part of this quotient rule problem. Then we're going to subtract the numerator function, 3x minus 7, times the derivative of the denominator. So when I find the derivative of my denominator function, x plus 2, the derivative of x is 1, the derivative of plus 2 is 0, so that's just going to be a 1 there. And then over the entire denominator function, x plus 2, quantity squared. Okay. At this point, just like with the product rule, now we're just down to the point where we want to use basic algebra to simplify this as much as we can, which is going to involve a lot of distributing and combining like terms. So here for this first chunk, I am going to distribute the 3 into the x plus 2 to get 3x plus 6. The second chunk here, where I have the 3x minus 7 times 1, that's just going to be 3x minus 7. But the biggest thing that causes people issues here is neglecting to distribute that negative through and or forgetting a set of parentheses here, which causes the same problem. So you definitely want to make sure to have all of your different components of the quotient rule in parentheses and remember to distribute that negative. So here we'll end up with minus 3x plus 7, whole thing over x plus 2, quantity squared. And then when I go to combine like terms, I have a 3x minus 3x, those are gone. I have 6 plus 7, so I have 13 over x plus 2, quantity squared. And there is the derivative of the f of x function using the quotient rule.